SwayamPrabha. Digital India. Educated India.
Yeah. So, the other the design expressions what we have discussed, design equations for ideal reactors. Okay. So, for batch you have T by C A naught equal to 0 to x a dx a by minus R a. For P f, V by F a naught equal to 0 to x a dx a by minus R a. M f equal to V by F a naught equal to x a by or x a f by, this also x a f by minus R a. To be very precise, I should write minus R a f, because I have written here x a f, because that is rate corresponding to only at the outlet. Okay. Yeah. So, these are the three equations which we have derived. We spent lot of time in understanding what is batch ideal, plug flow ideal, mixed flow ideal and all that. Finally, you have very simple equations. The simple equations have come because we have very beautiful assumptions. What is perfect mixing, what is ideal plug flow, what is ideal batch. Because of those equations assumptions only, you could get very simple equations, right. Good. So, now if you go back to your that information required for reactor design, this is input, output, kinetics, and I have contacting. Then here we have batch, continuous, PF, MF, okay, that way. This is physical, chemical, right. So, this is the design information required for the design. This all kinetics will give me minus R a. This will give me what? The reactor volume only, but I think what volume you are talking? Okay, reaction mixer also not the one. That the entire thing will give you what kind of reactor you have to use first. Contacting. Okay. So, you have to choose that whether you have to batch or continuous, and out of that you have to choose now. You see, so many times repeating also you are not able to get still the points, you know. Yeah, all this will give me the type of reactor which I have to choose. This suddenly will not give you the rate as someone was telling, Abdul was telling, conversion. How can you get conversion the moment you take contacting? Okay. So, you need again for get conversion, you need what kind of reactor you are going to use, what is the rate expression, and what is the input. Okay. So, now these are the then output will be volume if conversion is known, or conversion if volume is known, that is all. Okay. So, now by deriving these equations, what are the quantities you have now with you? Very good. What kind of reactors we have discussed. So, how do you choose we have discussed. So, that means I have information on this. Okay. Yeah, then that is all. That is all. What is performance equation? Output equal to a function of input, kinetics, contacting. Yeah. Okay. Yeah. So, what is the information till now we have covered for that using yeah, from for this equation, if you want to calculate finally either volume or conversion. What is the information? You said contacting, you know, that means you know how to choose a reactor. Okay. So, then you know again kinetics, we do not know, we have not discussed anything about how do you get this minus R A, okay, this minus R A, right. So, then what about output, sorry, what about input? Input did we discuss?
It is based on
What,
the
Savita? Not discussed. Huh?
market.
No, sir, based on the kinetics we can.
Student.
Based on the output we can do.
Okay. Yeah. So, input we have never discussed. Input we never discussed.
Sir,
FA naught we have never discussed.
we can decide the output, but we cannot decide the input. Only by the rate we can decide the input.
Devayan, how do you get FA naught we have not discussed?
From the output we have from the output we can.
Yeah, that is the first thing we know before starting any plant. What, Abdul, what has happened?
We first fix the output, sir.
Yeah, you have to produce some output. For that, you know what is the kind of reaction stoichiometry, and then how much reactants you have to get. I was telling you so many thousands of times that FA naught we know, FA naught we know, FA naught we know. FA naught is input. In your language, FA naught is what? Input. So then why do you say that? Then why do you say that input is not known? We have not discussed. So many times we have discussed about input, and then I was telling you that if you don't have time, appoint a MBA guy and then get all the, ask him to do the market survey and get what is the total capacity for this plant we have to design. So, FA naught is the first thing you know. I think what I told is that you identify a product and find out which stoichiometric equation is giving you. From there you are calculating what is the amount you have to produce. Amount you have to produce is a product, and now how much reactant you have to use. So, that is what is FA naught we know in the beginning itself. So, right now what you do not know is only minus R A. You know FA naught, right, and you know you do not know minus R A. But this equation or this equation or this equation, which you have equation you have to use will come from contacting, right. Whether you take batch reactor, whether you take continuous reactor, or in continuous reactor again you take PF or you take MF, all these things we have discussed. So, that is very clear for you now. Okay, just to take the sample. Gopinath, when do you choose mixed flow reactor?
Exothermic reactions.
Exothermic. When do you choose mixed flow reactor?
Highly exothermic.
Janvi?
Exothermic reaction.
Yeah. First of all, liquid phase reactions. High residence times will come. Mixed phase, most of the time liquid phase reactions. Okay. Then even if it is gas phase, sometimes if the temperature control is very crucial, then temperature, when you have exothermic reactions. So, under those conditions only you choose mixed flow reactions. Okay. When do you choose batch reactors? Debayan?
Small scale production.
When I ask Debayan, except Debayan, everyone talks. Okay, tell me. Okay. So, small productions like maybe 10 tons, 50 tons, 30 tons, you go for batch, but I think somewhere 80, 100 and all that we do not know which one is right, but definitely 1000 tons per day is continuous. Okay. So, that is why you have all the information. I think do not disappoint me, because so much time I have now spent on contacting, so that will be permanently printed in your brain, but it might be printed, but you are not able to recall. That information recalling also is important. No, what is that? Random access memory, RAM. So, that access is not there, you are printing somewhere. I think computer also stores somewhere, but to get that file out, your interest must be there. You should not forget so easily. Okay, anyway, so all this we have spent lot of time in deciding which reactor you have to use, whether this reactor, this reactor, this reactor. That comes from this. This is what type of reactor, and this is what FA naught, and now we have to find out what is minus R A, right. Okay. So, now let us talk about rate of reaction. I just started that a little bit, rate of reaction. Mainly it is our key reactant minus R A we call, and I may have a rate A going to R, general rate, or it may be having any complicated rate, right. So, how do I determine my rate, and we are talking first about the homogeneous systems, and then we can talk about heterogeneous. Homogeneous means either I have gas phase reaction or liquid phase reaction, everything is available in that phase. If there are two reactants, two liquids thoroughly mixed, two gases, you do not have to do anything, they will anyway thoroughly mix. Okay. So, we are talking about only gas phase or liquid phase for homogeneous reactions. Now, if I have homogeneous reaction between A and B giving me R L, how do I know what is the order of reaction? Okay. Or I may have A gas going to R gas plus S gas. I cannot have R and L and G, because that will become heterogeneous system. Okay. And before this we have also defined now what kind of rates you can express, like homogeneous means mostly it is liquid, volume of the liquid, or volume of the liquid. Otherwise, you have many possibilities for heterogeneous systems, that will come a little bit later, but this one. So, if someone tells that okay, I have now A plus B going to, now onwards please write in the bracket what is the state of the reactant when it is reacting, not at room temperature, when it is actually reacting. Okay. You may have both A and B liquids at room temperature. So, under actual reaction conditions both may be vapors. So, that is again homogeneous, but gas phase reaction. Now, you have to see whether the reaction time is very small or large. So, depending on that, so because you have the reactants liquid phase does not mean that you choose only CSTR. We are talking about those conditions, we are talking about whether gas phase or liquid phase at the time of reaction only, because the small things also you know sometimes you may not get the idea. I have now this is first order, but how do you know it is elementary? When I just asked you, how do you know it is elementary?
It depends upon.
Pooja, you are telling something?
If it takes one single step, then it's called elementary.
How do you know it? You cannot see the
using by
actual reaction
experiment.
whether it is
By
taking place in
experiment.
single step or two steps. You do not know. Yeah, that is very important. So, you can never say anything about the rate equation or order of rate or what kind of rate equation you get unless you conduct experiment. So, that is why chemical reaction engineering always associated with the experiments. So, do not tell very proudly that no, I am I Fonda guy. So, I only talk about mathematics and I cannot conduct any experiment. You have to conduct experiments. Okay. So, otherwise you will never get a rate expression, but if it is already someone did and then if you are copying is very easy, you can do many things. Okay. So, that is not the one. So, always reaction engineering associated with experiments, because the first thing I do not know is whether this reaction is elementary or non elementary, I do not know. Then what kind of rate form I will get, I do not know, right. And I will ask you another question. I have 2AL plus 2BL giving me RL. What is the order of reaction? Can I take this one as elementary reaction?
No.
Why?
Order greater than 3.
3.
Why order greater than 3? I mean, why are you very angry with orders greater than 3, or why you do not like orders greater than 3?
It does not take place.